Once upon a time, in a land far away, in a time long ago, there was a place called Land of Right Triangles. And in this land of right triangles, there was a king, King Trigonometry. Now, King Trigonometry owned all of the right triangle land. But he was getting up in age and he needed some help taking care of it. So he called upon his 3 sons. He sat up in his castle at the top of the perch in Castle A, because he had 3 of them. But he did all of his work and watched his sons from this Castle A. So he told his first son, Sine, he said, "Son, you are in charge of all the land that is opposite of me and hypotenuse of me." So Sine took care of all the land opposite and hypotenuse. Then he went to his next son and said, "Cosine, Cosine, son of mine, you are in charge of all the land that is adjacent and next to me and hypotenuse." So cosine took care of all the land adjacent and hypotenuse. Then he went to his third son. He said, "Third son, tangent, from where I stand at my Castle A, you are in charge of all the land that is opposite and adjacent." So all around town, because of their kind of checks and balances of having to take care of the land, they became known as the SOHCAHTOA brothers. Sine, opposite hypotenuse; cosine, adjacent hypotenuse; tangent, opposite and adjacent. But these SOHCAHTOA brothers, they had cousins, because King Trigonometry had a younger sibling. And they wanted in on this action. They're like, wait, just because our parent wasn't a king or queen doesn't mean that we can't do something. So King Trigonometry said, "Yes, cousins, you too shall be part of my land." So he said, "Cousins, cousin Sine, you're going to, Sine's cousin is going to be cosecant. And cosecant, you're going to take care of hypotenuse and opposite. Cosine, your cousin secant, is going to take care of hypotenuse and adjacent. And tangent, cousin cotangent, is going to take care of the land adjacent and opposite." Now, they didn't have a cool name like the SOHCAHTOA brothers. They were just called the cousins, because, let's face it, they weren't royalty. So the cousins are the reciprocals of the SOHCAHTOA brothers, sine, cosine, and tangent. Now, none of them liked using their full name, so they all abbreviated. Sine went by S-I-N, cosine, C-O-S, tangent went by T-A-N, cosecant was C-S-C, secant, S-E-C, cotangent, and C-O-T. And together, the majors and the cousins work together to protect right triangle trigonometry land. The end. All right, so what we're going to be doing is we're going to be using these 6 trig functions. And what's important about these 6 trig functions is that they always need to come from the angle that it's referencing. So in this particular story of mine, I always came from angle A. However, if I didn't come from angle A, let's say I came down here from the guest house in angle B, then my sides, adjacent and opposite, change their relationship. This would become opposite, and next to it would become adjacent. Hypotenuse never changes. Hypotenuse is always across from the 90-degree angle. But the sides, opposite and adjacent, do switch based on the acute angle that I'm going to be coming from. Now we're going to be able to solve triangles based on this information. So let's look at an example. If I give you the triangle and I say this is 28 degrees, this is 15, and that's x, what you always want to ask yourself is, how are the sides related? What function do I use? And then I want to set up and solve. So according to my angle, 28 and x are opposite, and 15 is across from the 90, so it's the hypotenuse. So now that I know I'm related with opposite and hypotenuse, I need to determine which function am I going to use. And when we set up a function, we always set up a major. We never set up a cousin. So I'm going to set up with sine, because that's opposite and hypotenuse. Opposite and hypotenuse. So sine of my angle, and this is always written together. You don't write a function without an angle. Sine of an angle is opposite over hypotenuse. Now when we go to solve this, we would multiply out the 15, and we can type that straight into our calculator. We need to make sure our calculator is always in degree modes for this particular part. Next year in pre-calc we use a lot of radians, but for a lot of us this year we're just doing degrees. I type in 15 sine 28, and I find that the side opposite, the side I'm trying to find, is 7.0 for whatever the measurement may be. I would like you to try this next one, where I give you this angle is 70, side is 4, and that side. I want you to try that on your own. Tell me how they're related, what function are you going to set up, and then solve it, and we'll go over that in class tomorrow. The next one I want to show you is how to do it if you're asked for the angle. When we're asked for the angle, you got to do a little bit different information. I'm still going to see I'm opposite and hypotenuse. So I'm still going to be setting up my sine function, but sine of the angle is opposite over hypotenuse. But in order to find angle, I have to get rid of sine. Well, I can't divide by a function. I can't divide by sine to separate those out, because x is not being multiplied to sine. X is part of sine. So in order to get rid of the part, I have to do its inverse. And on our part of it, inverse is whatever the function to the -1. And if I do it to both sides, I keep it equal. And that's how I get rid of a function, so that I can isolate an angle. Now on the calculator, what that means is that under or above my sine, cosine, and tangent, right above it, I see the inverse keys. So in order to get to it, I have to hit second, and then whichever function, in this case I'm using sine, and then 13 divided by 18. Now remember, when I do this inverse function, I'm always finding an angle. So make sure I label it as such with the little degree symbol. All right. You will be given pieces of information where you'll be asked to find or solve the triangle. So the first thing you're going to have to do is actually make the triangle. So if I say given triangle ABC, angle C is 90 degrees, find BC if AB is 4 and angle A is 22 degrees, you need to draw a picture. Then you can find your relationships, then you can set up your function, then you can solve it down and label appropriately if necessary. So what I would like you to do is work out this problem. I want you to draw a picture, and I want you to set this up, the function that you think you need, and then solve it down, and I'm going to check it tomorrow in class. All right, the last part of this is that you're going to be asked to solve a triangle. And what that means is you're going to find all 3 sides and all 3 angles. And that's my little symbol for angles, the less than symbol with a slash through it. So I'm going to give you some information. Now, if I give you small letters, those are sides. Capital letters are angles, of which, again, is a geometry issue. You should have gotten that from there. It carries over. So if I give you small sides, lowercase letters, those are your sides. If I give you uppercase letters, those are your angles. First thing you're going to do is you're always going to draw your picture. So you're going to draw your picture. It doesn't matter the orientation, A, B, C. As long as, if it says C is 90, that's the one you label. Then label the other information. So side A is 3, side B is 5. Again, from geometry, angles are across from sides. You're going to have to tell me all 6 pieces of information, even though 3 of them are already given. Now, when we go through this, sometimes you're going to know other properties to be able to use to solve this, and that's going to be fine. For example, I can find side C without doing any kind of trigonometry because I know Pythagorean theorem. And I can go 3 squared plus 5 squared is the hypotenuse squared, leg squared, leg squared. So I get 9, 25, 34. I get the square root of 34. Now be careful of the directions. If it says leave it as an exact answer, you definitely want to leave it as the square root of 34. However, if it says round your answer to the nearest tenth, you'd want to use your calculator to come up with that. So the square root of 34 is 5.8. So just make sure you're paying attention to the directions that are given. Exact, you'd want it simplified. So if it was like the square root of 8, you'd want 2 root 2. But 34 doesn't reduce. And if it says round, make sure you use your calculator and come up with a decimal answer. I could have, however, solved for C by using the trig if I chose. I could have chosen, let's say I use angle B, and I use side 3. So I could have said cosine of B is adjacent over hypotenuse. But I couldn't do angle B yet until I know that piece of information. So I'd have to hold off if I wanted to do trig. So let's jump over here to angle A and angle B. If I want angle B, here's my angle B, but I know 5 and 3, I would say 5 is opposite and 3 is adjacent. Therefore, I would go tangent of B is opposite over adjacent. And we learned that in order to find the angle, we do inverse. We can use our calculator at this point and round to the nearest tenth. In this case would just be 59. So I can use my fact of triangle sum is 180 and find A to be 31 degrees. Or I could have done the same thing and done tangent of A, but this time is 3 over 5. So A was the inverse of tangent, 3 over 5. And I still would have come out with 31 degrees. So whichever one you do, that's fine. Just make sure to show your work. So now that I know what B is, if I wanted to not do Pythagorean theorem, I could come over here and do the cosine of, and let's say 59 degrees. So C is 3 divided by cosine of 59. And we get the exact same answer. So whether I solve it with trig, solve it with Pythagorean theorem, use trig to find an angle, and then use the fact that a triangle is 180, or use trig to find the other angle, it doesn't really matter as long as I have the work to support whatever I found, and that I have all 6 pieces represented. So anytime you're asked to solve a triangle, you will always represent 6 pieces, 3 angles and 3 sides. All right, so that is trig number 2.